graphing y equals -2 tangent of 1/2 x. Let's find out a couple pieces of information, and I want to start with reminding you that remember that the normal period for both tangent and for cotangent is pi. So when we come over here to figure out our period, we're going to take pi divided by 1/2, which is pi times 2/1, so it's going to be 2 pi. So when we come over here and we label our grid 1, 2, 3, 4, here's 2 pi, so here is pi. As we look over there, we have nothing added or subtracted to this function, so there's no vertical displacement. But we do have a negative in front of the 2, which is in front of the function, so we are going to reflect over the x-axis. Eventually, with our domain, we're going to get to the point where it's all real numbers such that x doesn't equal something times n, where n is, and we'll have to finish that. And then the nice thing about the range for tangent is that it's all reals. But really what we would want to do is we want to graph this, and one thing that I can recommend is that you go back and you look at your tangent notes for a minute, because there really is kind of a pattern to this, and what we need to recognize is where are the asymptotes going to go on this. And where tangent has an asymptote, because it has an undefined value, is at pi/2. But if you go back and you look at the pattern in terms of where the asymptotes are from your tangent notes on page 28 in the packet, what you see is that tangent's going to have an asymptote here. And it's going to have an asymptote here. And check with Mrs. Krause, she's your teacher, but here's how I think of it. Thought of 1/2 times pi. Well, 1/2 times pi is pi/2. And that's why we have our asymptote right there. Now, once we get the initial part, the initial asymptote in there, then we can just keep counting. 1, 2, 3, 4. Here's another asymptote. Or we can go the other direction on the left here. 1, 2, 3, 4. Sorry, I'll try that to make that a little bit straighter. But we've got some things to deal with. But tangent of 0 is still 0. And now, tangent of our next value that we would have graphed would be pi/4. So we're going to go one space to the right, but instead of going 1 up, we're going to go 2 up and reflect our graph over. So we end up down here. We're reflecting the graph over the x-axis. So what happens for our other value, if you again look back, what we would have done then is we went one space to the right and 2 down, so we're going to go one space to the left and 2 up. And here's our first tangent function. And once we get that value, we can copy it. We copy it here. Or we can copy it here. And we can even have partials, which would be here, or a partial here. So there's the tangent function with the reflection over the x-axis and the vertical stretch of the 2. But more importantly, what we need to look at to finish this problem is, well, what is our domain? And as we look back here, once again, this value right here, our first positive asymptote is pi, n. And then what we can notice here is that our next asymptote's at 3 pi. If we were continuing, our next asymptote would be at 5 pi. And just to point out, this is pi times 1. Or it's pi times 3. Or it's pi times 5. And what we notice about those red numbers is that 1 and 3 and 5 are where n is an odd integer. And there's our domain.